Explore the incredible world of nanotechnology, where science works at the atomic scale. Nanotechnology is the manipulation of matter at the nanometer scale, where unique physical and chemical properties emerge. Let's understand what nanotechnology means and why the scale matters. Nanotechnology involves working with materials between 1 and 100 nanometers in size. 1 nanometer equals 10 to the negative 9 meters, incredibly tiny compared to everyday objects. To visualize the scale, a human hair is about 80,000 nanometers wide, while nanotechnology works at dimensions thousands of times smaller. At the nanoscale, materials exhibit completely different properties than their bulk counterparts due to quantum effects. Several fundamental principles make nanotechnology unique and powerful. As particles shrink to nanoscale, their surface area to volume ratio increases dramatically, making them much more reactive. The same volume divided into nanoparticles has exponentially more surface area exposed, leading to enhanced properties. At nanoscale, quantum mechanical effects dominate, causing materials to display unique optical, electrical, and magnetic properties. Nanoparticle properties do not equal their bulk material properties, opening doors to revolutionary applications. Nanotechnology has transformative applications across multiple fields. In medicine, nanoparticles can deliver drugs directly to cancer cells, minimizing side effects and improving treatment effectiveness. Nanotechnology enables smaller and faster computer chips, with transistors now measuring just a few nanometers. Nanomaterials improve solar cell efficiency and battery storage capacity for cleaner energy solutions. Nanostructured solar panels capture light more efficiently by utilizing quantum dots and other nanomaterials. Two main approaches exist for creating nanomaterials: top-down and bottom-up. Top-down approaches break down bulk materials into nanostructures using techniques like lithography and etching. Bottom-up methods build nanostructures atom by atom, or molecule by molecule, through chemical synthesis and self-assembly. The future of nanotechnology holds revolutionary possibilities across all fields. Scientists envision molecular machines and nanorobots that could perform precise tasks inside the human body or manufacture materials atom by atom. Nanobots can navigate through blood vessels to detect and destroy disease at the cellular level. Nanomaterials enable self-healing materials that repair damage automatically, and smart fabrics that respond to environmental conditions. Nanofilters and reactive nanoparticles could revolutionize environmental cleanup by removing pollutants and purifying water at unprecedented efficiency. Despite its promise, nanotechnology faces important challenges that must be addressed. The health and environmental effects of nanoparticles are not fully understood, requiring careful study and regulation. Producing nanomaterials at industrial scale remains expensive and technically challenging. Safety concerns center around potential toxicity and environmental impact, requiring rigorous testing and ethical guidelines. Let's recap the key points about nanotechnology. Nanotechnology operates at the incredibly small scale of 1 to 100 nanometers. At this scale, materials exhibit unique properties due to quantum effects and high surface area. Applications span medicine, electronics, energy, and environmental science. The future holds revolutionary possibilities, from nanorobots to self-healing materials. Nanotechnology represents working at the smallest scale to create the biggest impact on our future.